So finishing up on the ureters and the way they enter into the bladder, because they come in at an angle. As the bladder fills with urine, the opening into the ureters or the urethral orifices close up because of the pressure as the bladder fills, and that's beneficial so that as the bladder fills with urine, there's no backing up of urine back into the ureters. So it's a convenient structural design. So looking into the ureters, if you do a cross-section, the mucosal lining, in terms of the layers, the inner mucosa, it's transitional epithelium. If you remember, that's that type of epithelium that can stretch considerably. It appears to be stratified cuboidal epithelium when the ureter is empty. But we just refer to it as transitional epithelium. Then there's a muscular layer of smooth muscle, and it has an inner longitudinal and an outer circular layer of smooth muscle. And then outermost, there's the connective tissue adventitia. And then peristaltic contractions of the muscular layer about every 30 seconds help propel, push the urine down into the bladder, urinary bladder. So let's get into the urinary bladder. It's a nice muscular sac, smooth muscle for urine storage. Internally, it has some some convoluted surface features that are called rugae, which are similar to the rugae in the stomach in the sense that they allow for the urinary bladder to stretch. The trigone is a triangular region that's bounded by the two urethral openings and the urethral opening. It's this region here. And there are 4 layers or tunics to the urinary bladder. The inner mucosa is transitional epithelium. Here we go. Like we see in the ureters. Then there's a submucosa. And then the muscular layer is the muscularis, and there's 3 layers of smooth muscle. So combined, that muscular layer is referred to as the detrusor muscle of the urinary bladder. And that's what contracts to force urine out when we urinate or micturate or pee. And then lastly, externally, on the outermost layer or tunic of the urinary bladder is the adventitia. Here it's referred to as the serosa. And then finally the urethra, the passageway for the urine from the urinary bladder out into the environment. It is a muscular tube, smooth muscle. It has an internal urethral sphincter, which is under involuntary control, meaning it is smooth muscle and it is controlled by the autonomic nervous system to contract or stay contracted when the urinary bladder is holding urine, and to relax and open to allow urine to escape or leave via the urethra. But sometimes you can hold your urine, right? Because you have a voluntary skeletal muscle, the external urethral sphincter, which is shown here. The external urethral sphincter that you can voluntarily contract, and it'll close off the urethra so that you will not urinate until you are ready to urinate when you're at a place where you can urinate. And by contracting the external urethral sphincter, you can delay the micturition or urination reflex for a certain period of time. In the female, the urethra is about 1 inch long, and it is superior to the vaginal opening. The urethral opening is there. There's the vaginal opening. And in the male, the urethra is considerably longer because the urethra travels through the prostate gland, but more importantly, in terms of length, through the penis, So the urethra in the male is about 7 to 8 inches long. It has 3 sections, think PMS. The first section is the prostatic urethra, and that's the portion of the urethra that goes from the bladder through the prostate. Then the membranous urethra is relatively short, and it goes through the muscular pelvic floor, and it is surrounded by the external urethral sphincter, here color-coded in green. And the longest portion of the urethra is the spongile or penile urethra, and it goes through the penis, ending at the external urethral opening at the head of the penis or the glans penis. So the urinary reflexes. So the bladder can stretch quite a bit, up to 1 liter of urine. We usually have to urinate or micturate before we actually are holding 1 liter of urine. So micturation is also called urination. So the urinary storage reflex, sympathetic activation inhibits micturation. It inhibits the detrusor, meaning the detrusor will not contract. And it stimulates the internal and external urethral sphincters to remain closed, to prevent urine from simply trickling out. Okay? The urinary voiding reflex, to actually micturate or urinate, this is the parasympathetic innervation. So parasympathetic innervation activation stimulates micturation or urination by contracting the detrusor muscle, right, the muscular layers of the muscular layer of the urinary bladder, and relaxing the internal and external urethral sphincters. So then urine will start to work its way into the urethra. We can feel this, and if we're not in a place where it's readily convenient to urinate, then we can take conscious control of the external urethral sphincter and close that off and hold our pee, right, hold the urination until it's convenient for us. And by doing that, we can delay the voiding reflex, urinary voiding reflex, for a certain period of time. But as we all know, we can only hold it for so long. The next time we get the urinary voiding reflex initiated, it will be stronger because the urinary bladder will be holding more urine. And then more urine, at a certain point, we cannot hold it any longer. So emptying the bladder will end the voiding reflex, the urinary voiding reflex, because the bladder will then empty and it will not stimulate the urinary voiding reflex at that point. Okay? Because when you have to pee, well, you have to pee. Okay, we're done with this chapter.